Welcome back. Let's do one last linearization problem. All right, so here we have implicit differentiation. All right, that means we're going to have an x and a y value as part of A. So the value that we want to approximate is 1.92. A, the value that we're using, is 2, and when x is 2, we know y is 1. All right, so that's our whole point there. And if they didn't give us the y value, we would just plug in x and solve for y, but they gave us both. All right, and then we need the change in x. All right, so that's going to be 1.92 minus 2, so that's going to be negative 0.08. Right, and now we need to find the derivative as part of our linearization models. Reminder, the linearization model, if we are approximating some value, we take that friendly value, right, actually not a, f of a. We take that friendly value and plug that into the function. Right? And then we add the derivative times the change in x. Right? There's our formula. Right? And we have the change of x. We have the whole point 2, 1. So we already have the when we plug in 2, we get 1. Right? So and I could actually write that as, let me just write that clear. So if a is 2, then f of a is 1, right? Because x, y is implicitly defined within the function. So now let's find the derivative. The derivative's got a lot going on because we have a product rule, 2 product rules here. So let's just take care of each of the product rules first, then we can find the derivative. All right, so for this part here, x squared times y, u is x squared, derivative is going to be 2x. All right, v will be y, and the derivative is dy dx. For the other portion, the other product there, 2xy cubed. All right, so u is 2x, the derivative is 2. And v is y cubed. The derivative is 3y squared. Uh-oh. Can I fit in the... Here, let's just move this over a little bit. Oops, not that. This. There we go. Can't fit that in. dy dx. All right, so let's find our derivative now. All right, so I'm going to take the whole derivative there. So we have the first, which is x squared, times the derivative of the second. So that would be dy dx, plus the second, which is y, times the derivative of the first, so 2xy, plus the first, which is 2x, times the derivative of the second, which is 3y squared, dy dx, and then plus the second times the derivative of the first. So that would be 2y cubed, and then derivative of 8 is 0. We need to get the things with the dy dx's on one side and the things without dy dx's on the other. Let's just move the 2xy and the 2y cubed. So we have x squared plus, excuse me, not the dy dx there, x squared dy dx plus 2x, oh, let's simplify that. Multiply the 2 and the 3 together, that would be 6xy squared dy dx equals negative 2xy minus 2y cubed. And then if we factor out dy dx, we have x squared plus 6xy equals negative 2xy minus 2y cubed. And then divide both sides by x squared plus 6xy. So that would give us a derivative of negative 2xy minus 2y cubed over x squared plus 6xy. No reducing there. There's no common terms. All right, so now we need to plug in, all right, and find the value of dy dx and that would take care of that part right there. All right, so we plug in 2 for the x and 1 for the y, so that we can then approximate the value of 1.92. Right, so we have dy dx equals negative 2 times 2 times 1 minus 2 times 1 cubed divided by 2 squared plus 6 times 2 times 1. Tangled on my own cord. All right, so that's going to give us, on the top we would have, I'm just going to just do it in my head and write it down because we're running out of space here. So that would be, that is a negative in front. It's not really clear there. All right, so that would be negative 4 minus 2, so that's going to be negative 6 on top. And then 4 plus 12, it's going to be 16. So that would reduce to negative 3/8. There's dy dx. And now the only thing left to do is plug in to our linear approximation formula. There we go. So, actually, I'm just going to move this down. Oh, of course it's going to move in pieces. All right, so we are approximating 1.92. F of A, if we were to plug in 2 into the original equation, which you can't see anymore, but it's up here. If I scroll up, there we go. So we can see that it's x squared y plus 2xy cubed equals 8. If you plug in 2, you get 1 for y, and solve for y, you get 1. Oh, you can ignore that problem there. That's going to be for you guys. All right, so all we got to do is plug in now. So L of 1.92 equals 1 plus the derivative was negative 3/8 times the change in x. Let's change that to a fraction. So if it's negative 0.08, that's the same as negative 8/100. Oh, that's going to reduce out nicely there. All right, so that's going to be 1 plus, that's going to be 3/100. And simplify so that we have a common denominator. Our final answer is 303/100. Is going to be the approximate value of 1.92. All right, so that's the end of this podcast. All right, and in the Nearpod, you'll have a question like the one you see down there. Now, I was kind. I didn't give you a product rule, but I did give you something that was implicitly defined. All right, so thanks for watching, and bye for now.